This section is on real zeros of polynomial functions, and basically we are going to either be solving or factoring polynomials. This is one of our longest sections of the book. We're actually going to have 3 parts of notes to this section, and this is part 1. So what we're going to focus on today is dividing polynomials, and our goal is to factor. But I want you guys to realize that factoring and dividing are basically the same thing. Factoring is what we call division of polynomials. So here's an example of a multiplication problem. If you had x plus 5 times x minus 2 and you multiplied it out, basically if I'm going this way, that's multiplying. Well, if I go backwards, if I start with this one here, if I start with the answer and work back to the factors, that's what we call factoring, or basically dividing. I mean, the opposite of multiplying is dividing. So when you're talking about factoring a polynomial, what you're really doing is dividing. So before we get to the factoring part, I want to focus on 2 different types of dividing polynomials. And the one for today is polynomial long division. Now, polynomial long division, the first method we're going to study, is actually a lot like when you did long division in elementary school. The only difference is there's x's in there now. So basically, just as a refresher to lead into what we're going to do, I'm just going to walk through like a 2nd or 3rd grade problem with you guys and do long division from elementary school. So let's say we had a number like a pretty big number like 2053, and we are going to divide it by 7. And we're not allowed to use a calculator or anything like that. We have to do it on paper by hand, long division style. So the first thing I want you to remember about this process is when you're doing these problems, you don't look at the whole number. You don't look at the 2053, you just look at the beginning of it. So you look at the very first number, it's a 2, and you say, well, 7 doesn't go into 2. 2 is not big enough. So you go 1 digit over, and you're basically looking right here at the 20. And you go, yeah, 7 does go into 20. The most times it can go is 2, because 7 times 2 is 14, but 7 times 3 is 21. That's too big. So basically it goes twice. And you write the 2 there, and the 2 is the first part of your answer. So you have one part of your answer, but you got to figure out the rest. So the next step, once you found one part of your answer, the 2, you go 2 times 7, you multiply it by that number out in front, and you write it under the 20. Well, 2 times 7 is 14, and then you subtract those numbers. 20 minus 14 is 6. So that's one cycle of long division, and what you do is you repeat that until you're done. You take whatever's left over, the 5 and the 3, and you drop them down. Now you have 653. And you say, okay, well, let's do the exact same thing again. The first number is 6. 7 doesn't go into 6. It's not big enough. So I'm going to look at the 65. I'm basically going to look right here. That would go 9 times. 7 times 9 is 63. 7 times 10 is 70. It's too big. And then once you realize that, you multiply again. You take the 9. 9 times 7 is 63. You subtract. You get a 2. Drop down the 3. And then do one more time. So basically it would be 3 this time. And you would go 7 times 3 is 21. You'd subtract and you'd get 2. Now once you get to a number that's too small to divide by 7, that's called your remainder. And the way a remainder works, if you're answering in a fraction, what you do is you take that remainder and you put it over the number you are dividing by. So my final answer to that question would be 293 and 2/7. That's what you get when you do 2053 divided by 7. Now, obviously, that's not what we're doing right now. You guys did that a long time ago. I just wanted to refresh on it because I think what you're going to see today, polynomial long division, is the exact same steps, except instead of just having numbers, you have powers of x. So let's talk about that next. I'm going to walk you through a little like step-by-step of how to do long division, then we'll do an example of one. So let's say we're doing, instead of 2053 divided by 7, just numbers, we're doing polynomials. So I'm going to call them P of x and Q of x. Those are just names of polynomials, and we're doing P divided by Q. So basically the first thing you do is you write it in long division form, like I did before. You write the P of x underneath that little division symbol, and then the Q of x goes out front, just like the 2053 and the 7. Right here, the first one, P, goes under the division bar, Q goes out front, and there's an extra step here that you don't have to worry about with ordinary long division. If there's a missing term, fill it in with a 0. Like what I mean is if it jumps straight from x to the 5th to x cubed and you have no x to the 4th, write plus 0 x to the 4th there because you want to have a placeholder for that spot for later. All right, so here's where we're going to start doing exactly what we did with the 7. You take the first term. Remember, we only looked at the beginning. We didn't look at the whole number, 2053. We just looked at the beginning, at the 20. We're going to do the same thing here. We're going to take a look at the first term. We're going to divide it by Q, and whatever we get is the first part of our answer. Then, just like we did with the long division, you take the number on top, you multiply by 7, you write it below, and you subtract. Well, we're going to take the number on top, or the term on top, multiply by Q, write it underneath, and subtract it. And then you get that repetitive cycle, just like we did until you get a remainder. And once you get the remainder, remember we had a 2 last time for our remainder. Once you get the remainder, you put it over the thing you were dividing by, which is Q. So the 6 steps I just typed out into the slide, I think probably would have seemed super confusing, just talking about P and Q and this and that. But if you can tie it in with what we did with the regular long division problems, hopefully it makes more sense. So to wrap things up today, I want to do an actual example with polynomials instead of numbers. So let's do that. Let's do this one right here. We have P of x divided by Q of x. We have kind of a bigger polynomial that's like our 2053 divided by a smaller polynomial that's our x minus 3. And we're going to write it in long division form. So I'm going to write out that long division symbol. I left a little space above it because that's where the answer is going to go. Now the first one goes underneath. So I'm going to copy it down. We have 4x cubed. Now before you continue on, notice this is what I mentioned earlier. We're kind of missing the x squared. It goes straight from the x cubed term to the x term. We want to have a place for that for later in case we need to subtract from it. So I'm just going to write plus 0x squared, meaning we don't have any. It's still 0, but I have a spot for it now. And then we'll write the rest, plus 6x plus 4. So I copied the first one inside the division bar, and I put a 0 for the one that was missing. And then the one I'm dividing by, x minus 3, goes out front. Now, when you go to figure out your answer, I said, remember, before we took the 7, and we only looked at the beginning. We're going to do that, and we're actually only going to look at the beginning of both. So the only places I'm going to look are the first term here and the first term here. And I'm going to divide those. Let me see if I can go off to the side here and do this. We have 4x cubed divided by x. Well, that's just going to end up equaling 4x squared. One x is going to cancel. That 4x squared, that's the first part of your answer. That's what goes right here. Okay, now, just like we did with long division, once you get the number up top, you multiply it by the thing out front, which in this case is x minus 3. You write it under the polynomial and you subtract it. So I'm going to take this 4x squared and I'm going to multiply it here. I'm going to write it underneath this and subtract it. Now it's basically like a distributive property. You do 4x squared times x is 4x cubed. And you do 4x squared times negative 3 is negative 12x squared. And that's why I wanted that 0 there. I had to have a place to line that up with. And then here's probably the place where people make the most mistakes. Remember, you are subtracting both of these. You're subtracting everything. So that negative 12x squared is actually going to turn into a plus because it's subtracting a negative. But before we get to that part, the one thing that should happen every time, if you did this work over here right, if you picked the correct term for the first part of your answer, this first thing should cancel every single time, because that's why we do it. So we have 4x cubed minus 4x cubed, that cancels. Then we have 0 minus a negative 12x squared. And remember, I said be very careful, that's actually plus. So I'm going to get a positive 12x squared here. And then this was like one cycle. Remember when I divided the 7 by 20 and I finished one little cycle? I said, okay, I'm done with one cycle. I'm going to keep repeating this until I finish the whole question. So what I have is, we'll drop down the plus 6x plus 4. Remember, drop down everything else. And then start over. And again, I'm only looking at the first term. And it's still the x over here. So for the next part of my answer, I'm going to do 12x squared divided by x, which would just be 12x after one of those x's cancel. It is positive, so what I'm going to put for the next part of my answer is plus 12x. And then multiply and subtract. See, once you get the cycle down, it's very repetitive. You're just doing the same thing over and over and over. So I'm going to go 12x times x is 12x squared. 12x times negative 3 is negative 36x. We are subtracting all of it. 12x squared minus 12x squared cancels. Minus and negative is going to become a plus again. So you have 6x plus 36x is 42x. I'm going to slide over here a little bit. And then you drop down the plus 4. Now one more cycle should do it for us. The last part of my answer, again, you're only looking at the first part here. 42x divided by x is just 42. Those x's actually cancel this time. That's a positive 42, so I'm going to put plus 42 right here. And then we multiply and subtract one more time. 42 times x is 42x. 42 times negative 3 is negative 126. We're going to subtract both of those. 42x minus 42x cancels. Remember, that should happen every time. Minus a negative becomes plus again, so you get 4 plus 126, which is 130. Now, I can't divide anymore. I've gotten to the remainder. Once what you have left over has a lower power of x than what you're dividing by, you can't divide it anymore. Now, what you do with the remainder, remember, is you go back and you put it over what you are dividing by. So my remainder, the final part of my answer, is going to be plus. It was positive, so I'll do plus. And it's 130 over x minus 3. And that's the final answer to the question. It's a little bit messy and crammed in there, but what you see written above the division bar, that's the answer. It's 4x squared plus 12x plus 42 plus 130 over x minus 3. Now, these problems tend to be a little bit long, but they're not hard. It's 2 or 3 steps repeated over and over and over. You just got to be careful. Don't make that one little mistake where you forget to do the, turn a double negative into a positive, or you forget to subtract here, because that'll throw the whole question off. So this is one of those questions where you just want to be very, very careful, go a little bit slower than you otherwise might, and just make sure you don't make that one little mistake.